Hello, welcome to the second session of the Geo-Industry Talks. And we are together with Dr. Jason Stocker from USGS. And we are going to have a look at the remote sensing trends and new solutions in data utilization and more realistic 3D models from global scale to the city scale. Hello, Jason. How are you?
Hi, Howard. I'm good, thank you.
Great. Before we dive into the topic, can you please tell us about you and what were you doing for your career and so on, please?
Sure. Yeah, I work for the United States Geological Survey. I am part of what's called the National Geospatial Program. Our mission is to collect topographic information for the United States. We have a program that I am directly involved in called the 3D Elevation Program. And the goal of that program is to get high resolution elevation data mapped for the entire United States. So in the conterminous, the lower 48 states and territories, we are collecting high resolution LiDAR. And then in Alaska, we just completed collecting with IFSAR, which we use to create about a 5-meter DEM product. So my job is really to both help with the strategic direction of that program, as well as connect new and novel applications to our data, which I think we'll talk about. You know, collecting everything is kind of what we do. And then on the side, I'm also currently the president of the American Society of Photogrammetry and Remote Sensing, which is a professional society.
Perfect, thanks. So we can say that your experience is in that perspective is very deeply related to creating a kind of 3D information of the globe and a part of the globe actually. So our topic is like, as I said before, we are talking about creating more realistic 3D models for the digitalization of the world and a new, let's say, the new era of our surveying stuff. So I'd like to start with that topic. We can clearly see that the remote sensing methods and data usage are getting increased day by day in every sense of markets, every sense of applications, from digital marketing to autonomous vehicles, etc. And it's also a very important topic that we are facing nowadays, such as global issues such as pandemics and food shortage, agricultural investments, and wildfires we experienced, especially this summer in the United States and southern part of Europe, etc. So do you think that, or how do you see the developments of getting this information, remote sensing information, and using this kind of information, coping with natural issues such as before I mentioned?
Yeah, so I think one of the critical pieces, and this is one of the things that we've been working on with the 3D elevation program, or 3DEP, is the first thing you really need is the base information. So you have to have the structure to be able to look at how these things are changing over time. You need to have a snapshot in time to compare to. And I think things like the Landsat program that USGS and NASA manage has really shown the value of that, where we have nearly a 50-year record of the Earth and using remote sensing to look at these kinds of changes. And for us, we're trying to apply the same type of mantra to the 3D realm. So, you know, we're working for the United States, at least right now, we're working on creating a 3-dimensional picture of the United States as a base. And then once we get this done, we started doing this officially as a program around 2015, and we're about 85% of the way done collecting LiDAR for the United States. And then, you know, the next step becomes how do we update this information? At what scales do we do? At what amount of change, in three-dimensional change makes sense to go back and recollect this information.
Yeah, perfect. So from global scale to smaller scales, such as cities, towns, and other landscapes, we also see that the detail that we are collecting from the field is getting more and more accurate and more realistic nowadays, especially the involvement of the structure from motion algorithms like SFM softwares, pretty known nowadays and popular amongst the surveyors and other disciplines. How do you see that? It's kind of GIS question, actually. How do you see that the combination of the satellite information and the lower or let's say photogrammetry or airborne LiDAR information in combination, how do you see that the combination of these three using in more realistic city models, and also you can answer this question in terms of smart cities in the future?
Yeah, so one of the things that we've noticed is the information that we've been collecting for the United States, it's at a minimum of about 2 points per square meter. And then we compare that to survey grade GPS out in the field to make sure that we contract all these different private sector companies to collect the data for us. And we have a standard and a specification to do that. So all these different companies collect data to meet our specification. And the reason for that is to enable the use of this type of multimodal suite of products, right? So in the surveying realm, where probably most of the people watching are more familiar with, the density of data and the accuracy has to be very precise, millimeter, centimeter level. For our national scale applications, we've started, and it's about a 10 centimeter RMSE is what we look at to have compared to survey grade data. And we've noticed the appetite from the airborne systems has been higher density, higher accuracy data, and to the point where some of the rules of thumb that we used to employ, for example, to evaluate the airborne data, the survey had to be at least 3 times as accurate as the airborne data for us to validate and assure it. Well, now that we're getting down to these levels of accuracy and density as part of these airborne collections, you have to change the surveying procedures because the surveys have a couple centimeters of error in them. And so when you start getting down to evaluate 5 centimeter RMSE, you need a much tighter survey to assure that that data is as accurate as it says. So that's, when it comes to the GIS problem, that's kind of how we've been looking at it, is making sure that we provide this data to the public for free, and we make it available, and people know the quality and the consistency of the data, so they can tie all these various data sets to it if they're aware of the uncertainties and the accuracies that we've achieved. So that really links at least what we've been focused on with the global remote sensing data all the way down to the survey level. Satellites that have been collecting 3-dimensional data like JEDI and ISAT-2 have been using our 3-depth point cloud and DEM data as their validation, because now we have enough data across the US at least to let them look at the accuracies of their global data sets in relation to something that they know has been measured even at the survey level.
Yeah, perfect. When you were talking about opening the data in use of public, So we can say democratization of the data. And it's also giving us many people the idea for starting up some new businesses. And it's very popular that people are using this kind of information for creating their own solutions for the local problems, as we talked before, such as agriculture, water management, and many other stuff like smart city management stuff. And also, it's been, as I see, been 2 years, maybe 3 years. It's been also a big portion of the gaming industry also. So people are using this kind of elevation information in 3D models that they are using in gaming engines. Perhaps you already know about the Unreal Engine stuff and Unity stuff. They are doing great in collaborations with other GIS companies such as Cesium very recently. And they are collecting this information, open information from the servers, and they create their own applications and developments in gaming engines. So this leads us actually another question. How do you foresee that combination of this big data, open data in gaming engines in terms of GIS reasons? And it's giving me a very clear vision. Actually, in my point of view, it's going to be like a metaverse that we are easily get into with our computers or I don't know, VR goggles, etc. And we will dive into directly the specific part of the Earth with a very high realistic 3D models. But I want to hear from you. How do you foresee these developments in this market?
Yeah, I think that's a huge growth area right now. And one of the things that we found early on is we couldn't be all things to all people as a government agency. So we've been focusing on, like you said, we've been focusing on the acquisition, the standardization, and then the dissemination of this data. So our focus has really been on getting the data packaged up, getting it acquired, getting it put in a place where anyone can come in and tap into it. And like you mentioned, we've seen a lot of businesses spin up, and I think we'll see even more in the future, just based on the availability of this free data. I've been really excited about, once I saw that Unreal Engine and Cesium were able to connect and use the LAS file format. I got really excited about that because one of the things that we do, I mentioned new and novel applications of our 3D data. Well, the best way to sell it is to have beautiful images and beautiful videos showing this is what our data does. You can do lots of measurements, which are really important for scientific purposes, but for the people that continue to fund us, showing the value of this data in a way that's that makes sense is really important. And one of the funny things is that I tried to get access to Unreal Engine as part of work, and our IT guys denied it because they thought I was just going to be playing video games at the office. So unfortunately, I haven't had the luxury of being able to dig into that part, but I'm really happy that we've been able to put our data out there. And I've seen, we have companies that have connected our data and made it available via Cesium. And so others can take advantage of that. And hopefully someday I can convince our IT folks, and, I'm really working and convince my bosses that these Oculus goggles that I'm asking for are not for fun. They're actually for work. And then
it's hard to believe.
yeah. And then the other thing that I think is really exciting is not just the visualization piece, but once you get into this immersive ability for us who are producing and making the data available, classifying data is very important. and being able to actually get into the data itself and look at it. I picture, we have algorithms that classify points as ground and non-ground in trees, but in the future, I can see, we have staff that are walking through virtual forests with their goggles and just painting points as trees as
it's gonna be fun, really. It's gonna be fun.
So I mean, a lot of applications.
Yeah, perfect. So just one question about your classification process. It's a parallel topic, but I would like to learn about your techniques and methods of classification. What do you do for classification?
So for us, as I mentioned, we have this specification that's defined as, when the companies collect data for us, these are the things, and a classification scheme is one of them, because being a part of the USGS and making topographic maps, our focus has primarily been on getting the ground and the non-ground points separated. So a lot of our effort goes into making sure that we have the ground points classified as best as possible. And we don't do that ourselves, but we do have staff that when the data comes in from the contractors, they go in and check it. But so our points that we provide to the public are minimally classified. We don't get, and it also depends on the partnerships that we're working with. But I think that's another opportunity. And we've seen some partners like the Natural Resource Conservation Service has gone back into our old data and then applied new classification methods to tease out even more classes out of this data. And so I think that's something that we've kind of set, like the base level of classification, but there's always new, you hear all the buzzwords about AI and machine learning to go in and classify points. And I think that there's a lot of possibilities there where we can achieve better classifications than we have. Sorry, I stepped on you.
Perfect. Another question about photogrammetry. How deep are you involved in photogrammetric workflow?
So, like I mentioned, so because our main focus is bearer DEM or DTM, we started the 3D elevation program. Photogrammetry wasn't a technology that we saw as being able to meet our needs, especially in forested areas. So for this first coverage of the United States, LiDAR has been our technology of choice. As we get that baseline data set together, now that we're looking at different kinds of changes, I think that photogrammetric solutions will become a tool that we will use because the acquisitions are a lot easier, a lot more rapid. You can get a lot more dense data. And if you're only interested in things like building changes, forest canopy changes, these solutions may be a lot more cost effective than going back in and getting another high resolution LiDAR collection. So we don't employ photogrammetry as part of the 3D elevation program yet, but I imagine as we look to the next generation, that's going to be one of the tools in our toolbox that we'll want to use.
Yeah, perfect, good. I want to continue with photogrammetry in usage in smart city applications. Recently, I was having a discussion with my colleague that in the workflow, we create point clouds out of photos, and then from this point cloud, we create mesh, and we analyze the mesh, clear the mesh to be able to use them in some specific areas. So it's mostly a dummy model, dummy 3D model that has the texture on it, and then the geometry, it's mere geometry. And the recent developments, as I'm hearing and seeing from the internet, that some softwares are developed, and these softwares, such as Hexagon Digital Reality, one of them is, I believe it's so nice, but it is not released yet, as I understand. But it is giving the semantic information into the meshes, on the meshes. So it gives you the ability to analyze, to get some feedback from the mesh itself, to give information and get some feedback from the mesh itself. So did you have any information, or did you have any experience about this kind of applications? Or it's a personal question, not on your professional side.
Yeah, professionally we haven't done a lot, but I do see the value in that, and I also, you know, have seen a lot of integration together of LiDAR and photogrammetry now, which gives you kind of the best of both worlds, right? The LiDAR is very accurate at a single location. What it's missing is the edges. And so when you get a photogrammetric solution, you're much better able to capture the edges of features, which do improve the quality of your meshes as well. And I know, you know, in the past that when we were creating models of urban areas, especially employing a digital surface model just from the LiDAR itself, looked like you just threw sheets over everything. You could not capture those discontinuous surfaces. And I think that and meshes and voxelization of the points, I think is also another way to look at the integration. And then in terms of semantics, we haven't done a whole lot of that because of our focus is usually not so much in the urban areas, because our partners in the cities and counties, you know, that's their focus, is basically comprehensively collecting as much data as we can, and then the partners end up doing those types of those applications. So I know enough about meshes to know that they've really kind of changed. And like you were saying, the gaming industry, I think, has really kind of helped that drive that and make that look as great as it does now, which is, you know, it's not just, you don't just have to have a pixel now with a color value. You can attach all of these things and have it look inherently 3D, which is amazing.
Yeah, cool. So I'm checking my notes and seeing that we already covered almost every single thing I already noted. But what we can do is that we have still like 8-9 minutes. We can either get questions, external questions from the audience, or we can keep going with other stuff that you are doing. How you like it?
I can talk. I guess I should have expanded on my answers a little bit more.
yeah, might be a good idea, actually.
One of the things that we are doing that probably this audience, I'm not sure how much this audience is looking at, but this is a big area of growth for us, for, you know, what's next, is we are starting to look at topographic information. So we've been imaging everything above the ground for a long time now, and now we have these green laser lidars that are able to penetrate the water surface up to a certain depth or certain clarity. And so for all of the data that we've been collecting where there's water, we have basically no information. So we flatten the water bodies, you know, use that as a water surface, if you will. And so we're starting to go back and look at, can we get elevation information for every spot above and below the water surface, across the country. So our colleagues in NOAA on the coast in the Army Corps of Engineers have been collecting topobathymetric LiDAR for years along the coast, especially after hurricanes, to map how things have changed, because coastal systems are so much more dynamic than a lot of other places.
Yeah.
And so we are looking to start to employ that technology inland into rivers and lakes, and where where the water either gets too deep or is too turbid, filling in those holes with sonar. So going out and collect, and then we are creating these complete merges of all these different. So we have the topographic LiDAR that gets everything above the ground surface. We have the sonar data collecting bathymetry in boats, and then our idea is to use the topobathy LiDAR kind of as the zipper, to connect
to
from these different data sets together.
Yeah,
so that's been something that we've been focusing on now, and then connecting that information. As I mentioned, our program is not only in charge of the elevation, the terrestrial elevation for the United States, but also the hydrologic information. So we have the NHD, and so generating the stream information directly from the LiDAR is something that we've started to focus heavily on. In the past, all of our blue lines, our streams came from, and our elevation came from those old topographic maps. So at one point in time, the stream information and the elevation information were aligned because they were both on the same maps. And as we started replacing the elevation information from the topographic maps with LiDAR, all of a sudden we had more accurate, higher resolution elevation information than we did hydrologic information. So we've started to go back and create processes that extract those hydrologic features from the elevation, so the data is perfectly aligned together. And that's been another critical piece that we've been focusing on.
Perfect. It's very nice to hear that, because as we are seeing from the news, especially southeastern parts of shores of United States suffer frequently from the tornadoes and natural disasters and so on. So it will be also very efficient way of monitoring the coastal changes and critical stuff. When we are talking about the United States, of course, the mostly populated cities are coastal line, such as New York, Washington, and it's very important to get this monitoring information from remote sensing tools, let's say. All right, perfect. So is there any question? Let me check my screen once again. I'm not seeing any. So let's wrap up for now. Jason, thank you very much for joining me for the session. And it's been a pleasure meeting you and doing this conversation with you. So thank you for joining us, and we will see, we'll keep on seeing you on the next sessions.